Okay, so we're on page 11 if you're not already there. And today we're doing the kite and the trapezoid. So on a kite we have two steps. So we find the distance of the length of all four sides. And you must have two pairs of consecutive congruent sides. So consecutive means beside each other. So a lot of you found on the warm-up that that was the kind of hard part. Kites sometimes are hard ones to see. It just means we have to have two sets of sides that are the same. And then the slopes of the two diagonals. So go ahead and take a minute and graph the shape on your paper. Yes, I graphed something wrong. What did I do wrong? G is supposed to be up. Thank you guys for raising your hands so quietly. Okay, did I graph it right now? And that'll be something to watch out for in your project, that you double check your lines if things aren't looking quite right as you're figuring out what it is. Okay, so we have it graphed. Our next step, who remembers what the next step is? Slope and distances. So we're going to find our four slopes. So GO, what do we call slope when it's straight across? 0. OA, who wants to count that for me? And negative 10 over 5. Did I count that right? You guys can answer my questions. What is negative 10 over 5 reduced to? Negative 2. Alright, and then AT is, wait, A to T. Also, negative 10, sorry, positive 5 over negative 10, or other way around, so that goes to negative 1/2. And then, what do we call GT? Close, undefined. Okay, so that's our slope. Then we're going to find distance. And so GO is easy. We just had to count. What's our GO distance? 5. AO, I already have the unreduced slope there, so like we talked about last time, I can plug it into Pythagorean theorem. 10 squared plus 5 squared, 125. Does anyone remember what that reduces to? 5 root 5, right? Because it's 5 times 25. AT, is it going to be the same thing? Yeah, because we have the same 5, now it's 5 squared plus 10 squared. But it's going to reduce to the same 5 root 5. And DT we can count. What's it come out to? 5. So now that we have distances, do we have enough to write one of our proof statements up at the top? Yeah, because it says we have to have two pairs of consecutive congruent sides. So my congruent sides would be GT and GO. So my first statement would be GT is congruent or equals GO. And then I'm going to go ahead and write the distance 5 there, just to make sure it's clear. And then OA equals AT, and I'll write my 5 root 5 there. So as you do your project next time, when in doubt, just go ahead and copy down the exact information there. It's always better to give more information than not enough. Alright, what do I need to find next? Yeah, my slopes of my two diagonals. So my two diagonals would be my TO and GA. And so to find the slope of them, I just have to count. From T to O, I go up 5 over 5, which is 1. and G to A is down 10 over 10, which gives me -1. Are those perpendicular? Yeah, because they're the opposite reciprocals. And so then my proof statement would be TO is perpendicular to GA, and I'll go ahead and put it's 1 and -1. So I have my evidence right there, and then the work is shown down below. So once you have all that, go ahead and flip over to page 12. So page 12 is actually just a second kite that we really don't need to take the time and notes to do it again. So we're going to skip over page 12 and go on to trapezoids, page 13. Alright, so on the trapezoid, for it to be a trapezoid, we have to have one pair of parallel sides and one pair of not parallel sides. Okay, so as you were seeing on your warm-up, that's what you have to look for in the trapezoid, because if it has two pairs of parallel sides, it's a parallelogram. If it has no parallel sides, it's either a kite or just a quadrilateral. And so that's going to be what we do, is we just do it off of our slopes. So go ahead, take a minute, and graph your Tate trapezoid. Alright, and then our first step after we've graphed it is slope. So what was my slope of KA? KA would be 2 over 3. How about A to T? I have -4/3, right? How about T to E? What? Yeah, 2/3. And the unreduced I'm going to put there is, it was 4 over 6, which reduces to 2/3. Because when we find distance, we use unreduced. And then what do we call EK? Undefined. So now let's go ahead and add in our distance. And so 2/3 would be our 2 squared plus 3 squared, which gives me square root of 13, right? And then 4 squared plus 3 squared, you guys know that one? Anyone have that one memorized? 25, square root of 25, which is 5. Alright, this next one, TE, is still 2/3, but we can see the lines are different lengths, so we have to remember to go back to the unreduced slope, where we have 4 on this side and 6 on this side. So that'd be 4 squared plus 6 squared. It gives me 16 plus 36, which is 52. Does that simplify? It can. I mean, 2 and 26, and then 2 and 13. So 2 root 13. And then the EK we can just count. What does it come out to when we count it? 6, right? Okay, so now that we have our slope and distance, let's go back and see what proof statements we can write. And so we have to show one pair of sides are parallel, one pair of sides are not parallel, and so I will write my KA is parallel to TE, and I'm just going to go ahead and put that slope in there. Those are both 2/3. And then AT is not parallel to EK, and one is -4/3, one is undefined. So that proves that I have a trapezoid. Now, whenever you have a trapezoid, you always have to do this next step to say whether it's an isosceles trapezoid or a regular trapezoid. And so we have to do diagonals are congruent using distance, and the non-parallel sides are equal. Do I have enough information to do either of these yet? Okay, lots of head shaking, so let's go ahead and find our diagonal distance. And so our diagonals would be KT and AE. I have a volunteer to tell me what the slope of KT is. Yes, you can now. 2 over what? So 2/6, which comes out, and is it positive or negative? Negative, so -1/3. And someone else, what's AE come out to? So that comes out to -8/3. Are those, does that give us what we need? No, what do you say, Lauren? No, you're right, that should be positive. Positive 8/3. Okay, so our diagonals, they aren't perpendicular, nothing's happening with them. What do we need now to find next? Diagonals are congruent using distance, right? So we're going to take those and just plug them into our Pythagorean theorem. 2² + 6², and that gives me square root of 40. Anyone knows what that simplifies to? 2√10, right? You guys are getting really fast with this. Alright, and then AE would be our 8² + 3². So 64 + 9, square root of 70, not 72, 73. Does that simplify it all? No. So are those congruent? No. Okay, so we can come up here and say KT does not equal AE. And we could go ahead and write in this 2√10 and 72, square root of 73. Alright, and then one last thing. So method 2, prove that the non-parallel sides are equal. So coming down to here, our non-parallel sides are the AT and EK. So if this was isosceles trapezoid, those would be equal. And when I look down at my list, are those equal? No. So I would say they don't equal each other, and go ahead and list it's 5 and 6. So then my conclusion is it is not isosceles. Okay, so on page 14 we're going to do just the top one here. And so go ahead and graph your milk. So looking at that, do you think that's going to be an isosceles trapezoid?
Oh, wait.
So it looks like it could be, but we still have to do the math and make sure. So what's our first step after we graph? Slope and then distance. So what is our slope of MK? 0. What is our slope of KL? And so our unreduced was 5 over 5, right? And then that reduces to -1. What do we call Li? Undefined. And Im, first of all, unreduced is 2 over 2. KL because we came down. Oh no, it's positive. I'm sorry. That is positive. Thank you for correcting me. Because it's -5 and then -5, so they cancel out the way I counted it. They were both negative. Alright, and then I to M is 2 over 2, so that's +1. And then our distance. So MK, what is our MK distance? 3. How about KL? We take that unreduced 5 squared equals 5 squared. Square root of 50. Who has that memorized? 5 root 2. Li, what is our Li? 3 again, that we can just count. And Im is 2 squared plus 2 squared. Who remembers square root of 8? 2 root 2. What else are we going to need before we finish all those proof statements? Diagonals. So did we end up needing the diagonal slope or just the distance? So we can find slope and then distance, or we can just do distance. So our diagonals distance, so that would be our LM and IK. So L to M, I go up 1, 2, 3, 4, 5. 5 squared plus 2 squared. So 29. Does that reduce or simplify? No, that stays that way. And then I to K, I go 1, 2, 3, 4, 5 over and up 2. Is that the same thing? Yeah, square root of 29. And so then for this I need at least 3 proof statements because that's what it listed on my page. So my first one is saying I have 2 parallel slopes and 2 lines that are not parallel. So I'll say KL is parallel to IM. MK is not parallel to LI. That's my first statement. My evidence is already listed right there, so I'm not copying it down again, but you always could if it's not clearly right beside it. I'll draw the arrow instead. What was my second proof on the page? Can you guys remember? Diagonals, I heard you say it. So that would be LM equals IK. And here I am going to go ahead and copy down because I have space. They both equal root 29. And my third one was distance of the non-parallel sides, right? So I already wrote that those MK and LI are my non-parallel sides. So MK equals LI. And I can either draw an arrow up there or just copy down that they're both 2 root 2. So therefore, it is an isosceles trapezoid. Yes. Did I list the wrong ones? Oh, you're right. I see what you're saying. MK and LI are both 3, not 2 root 2. Thank you for pointing that out. Alright, so once you have all that, go ahead and flip to page 15. We're not taking notes there, but I'm just going to show you how that can help you with your homework and your project next class. So this is a really nice diagram. This and then also page 5 are the ones I recommend you going back to if you're having any trouble remembering what to explain for each part. And so quadrilaterals, every single shape here is under a quadrilateral. You probably will have one on your project that is just a quadrilateral and does not have any of these other properties here. So be aware if it doesn't have any of the parallel sides or congruent sides or anything else, then it can be just a quadrilateral. But then this is especially what's important. You saw this on your warm-up. Parallelogram is always a quadrilateral. Rectangle and rhombus are always both parallelograms and quadrilaterals. Square is always all of those. And so when you're doing your proofs, you have to prove the multiple layers and make sure you're following everything for all the proofs there. Trapezoids, you always have to say that isosceles are scaling. Kites are standalone by themselves, so they're just quadrilaterals, and then they're the ones with the consecutive congruent sides. And then these angles kind of show you what you prove. The only difference is these talk about the angles, and in this unit, this project, we're not dealing with the angles. We're not like actually measuring and proving angles. We're just doing the sides, the slope and distance.